Hi, my name is Autumn Wilson. I'll be sharing a presentation about the art of tetrachotomy in AI, exploring the mathematical beauty of art in AI. So, to start with, I am an artist and archivist that's worked at the Smithsonian National Portrait Gallery, Christie's, New York, Atlanta University Center, and I have a BA in art history from New York University, an MFA in studio art from the City College of New York. I recently started a PhD program at Palm Beach Atlantic University in practical theology. So what is tetrachotomy? Tetrachotomy is the division of something into four parts, like the word dichotomy, which is the division of something into two parts. Today I'll be discussing Alan Turing and the imitation game, tetrachotomy, prime numbers and composite numbers, DALL-E and ChatGPT, and my spring show in Harlem. So Alan Turing inspired this presentation. His movie, the movie about him, The Imitation Game, in the very beginning, they're panning in his office, and there are drawings and pictures of his algorithms and his mathematical patterns. This movie was very instrumental. I've seen it hundreds of times in marking a division between man and machine, and that question and that conversation is very relevant today. So here's my storyboard of how I got here. Just a couple of images that you guys can kind of read, where I created a Venn diagram with numbers that just represents divisibility relationships. So the algorithm that I used to create the following images is here, and it reads N is divisible by four numbers that are different, A, B, C, and D as variables. A is divisible by two different numbers, X and Y. D is divisible by Y and Z. C is divisible by Z and W, and B is divisible by X and W. Where the numbers repeat, where the variables repeat, that's the same number. X is divisible by Roman numeral 1 and 4. Y is divisible by 2 and 1. Z is divisible by 2 and 3. And W is divisible by 4 and 3. 1 is divisible by E. 2 is divisible by F. 3 is divisible by G. And Roman numeral 4 is divisible by H. All are different numbers. So here you can kind of see where I came up with this statement. You just take a Venn diagram and you plug in numbers that have divisible relationships in them. So Y is represented by 6 and Z is represented by 10 and C is 60. So these numbers divide into 60, which divides into 120. And then there's these numbers on the outside of the Venn diagram. So these are the images that you get when you put that statement into chat and ask it to create an image. It's always the same image, and it's always structured the same way in these squares and these networks. As you can see at the bottom right, this is what you get when you put the algorithm into Python using Jupyter Notebooks. You can change the statement to include semiprimes at the very end, which are numbers that are only divisible by themselves or 1. So this is what you get when you put that into chat. And as you can see, it looks much like the Venn diagram where you have that outlier on the outside. So this is that image with the semiprimes. So you can solve this equation multiple times and then add those networks together, as you can see in these images. And you can even these images are from chat, replace some of these statements with words and other concepts like science and other concepts, and it creates some abstract image, which is pretty cool. So in Andrew Hodges' book, Alan Turing, The Enigma, the book that inspired the film The Imitation Game, it is said, although the prime numbers were such ordinary things, it was easy to pose quite baffling questions about them in a few words. One question had been solved very early on. Euclid had been able to show that there were infinitely many prime numbers. So because artificial intelligence is able to do the math on very high prime and composite numbers, it's very interesting to be able to get these structures quickly. So what I do is I take these images and sometimes paint them, and this is a description of that, a representation of that from my MFA thesis show, all that. So here are more images of that pattern, that recursive pattern that statement, that very first statement creates, no matter how many times you solve it and put it into DALL-E to create an image, it creates fundamentally the same image with this stacking. This image is created by asking chat to use the same structure of divisibility relationships and use addition, subtraction, or multiplication relationships, and that's all of those in one: multiplication, addition, subtraction, and division. Here's another image that is a bit more colorful of just that first statement. So in using the Venn diagrams, RGB color models in the CMYK color model uses a Venn diagram structure to explain the relationships between colors. The last model I created puts blue, green, and red in the middle, and cyan, yellow, and magenta on the outside, and black as the background. To show in science class, we learned that the color that you see is the one that is not being absorbed. So I was trying to go back. I was trying to create a representation of white in the middle that absorbs all colors, and the colors that are being reflected are slowly or reflected in order to black, which reflects nothing because it reflects black because it doesn't absorb anything. So yeah, that is a work in progress, but it's based on dividing into each other. So we're gonna skip that. If you have any comments or questions, please comment below or email me here. These are some of the other models I'm working on in Python and Chat and DALL-E. So they represent different algorithms that I'm creating. This is my last, one of my most recent images that I'm creating with Chat using language model algorithms, which is kind of what these are founded in, and creating some sort of math network image using them. So that's my presentation. Thank you. And if you want to subscribe. But yeah, thank you for the time.